today. This is what we did in class. Doing this with me will help catch you back up. So what we're doing is dividing whole numbers by fractions. Okay, so instead of using models today, we're going to use a sort of a shortcut method that will help us divide whole numbers by fractions. The first thing we have to learn how to do, though, is find what are called reciprocals. And reciprocals are a reciprocal of a number is a number that when you multiply two numbers together, you get one. All right? So for example, we have the number 2/3 right here. To find the reciprocal of 2/3, you'd think, well, what number could I multiply by 2/3 to get 1? And that number would be 3/2. Because when you do this, 2 times 3 is 6, 3 times 2 is 6, 6 divided by 6 is 1. So that means that the reciprocal of 2/3 is 3/2. That's the reciprocal. Now, if you look at these two numbers, it's almost as if it's the first number but just flipped. And that's kind of what a reciprocal is. It's kind of what it is. But we just have to be careful with that. For most fractions, yeah, it's just the number flipped. But for some, as we'll see, it's not quite that simple. So if we think of the number 1/8, to find its reciprocal, we think, well, what can I multiply by 1/8 to get 1? Well, that number would be 8/1. Because 1 times 8 is 8, and 8 times 1 is also 8. 8 divided by 8 is 1. So the reciprocal of 1/8 is 8/1, which is, it's just 8. So either number would work there. So I guess that one is also kind of flipped. If you flip 1/8, you get 8/1, but 8/1 is the same thing as 8. Okay? All right, this one is where it gets a little tricky. So 5. Okay? Finding the reciprocal of 5. Well, I think of 5 as a fraction would be 5/1. That's the same thing as 5. To find the reciprocal, we're thinking, well, what number can I multiply by 5/1 or 5 wholes to get 1? The answer would be 1/5. 5 times 1 is 5. 1 times 5 is 5. 5 divided by 5 is 1. So the reciprocal of 5 would just be 1/5. So this is when I say, it's not, reciprocals aren't just the number flipped around, because first, to flip it, you would first need to write it as a fraction, then you can flip it. So just be careful with those whole numbers, because you wouldn't just flip the number 5, because that would just be an upside down 5. All right, let's check out these ones. So you can try these ones on your own if you want. I believe that says 3/5. It's very tiny. But 3/5, the reciprocal would be 5/3, because 3 times 5 is 15. 5 times 3 is 15. 15 divided by 15 is 1. So the reciprocal of 3/5 is 5/3. Again, it's just flipped around. And you'll see in a moment why we need these reciprocals, or why we may need these reciprocals. 1/3. Well, 1/3, the reciprocal would be 3/1. 1 times 3 is 3. 3 times 1 is also 3. 3 divided by 3 is 1. So the reciprocal of 1/3 is 3/1, just flipped. Whoops, probably couldn't see that completely, but there it is. My apologies. Last one here, 11. Now, this is when it's a good idea to write 11 as 11/1, like that, right? So you have 11/1. What number would you multiply by that to get to 1? It would be 1/11, because 11 times 1 is 11. 1 times 11 is 11. and 11 divided by 11 is 1. So that means the reciprocal of 11 would be 1/11. So again, the answer to these, okay, to these 6 problems that we did, wasn't necessarily like, wasn't 1. I know we got to 1 for all of them, but we were trying to find the reciprocal. This is like the long way to find it. The short way to find it would be to flip the fraction, except for like the whole numbers, because you'd have to write it first as a fraction and then flip it. We're going to use this idea now to help us divide fractions. Okay? All right. So we're actually going to use, down here, we're going to use a little model here. We're not going to use models the whole time today, but I just wanted to show you another model to help you get an idea of like when would these reciprocals come in handy. So I'm going to just draw a little bar here. Excuse me. And we'll do 5 divided by 1/2. Okay, 5 divided by 1/2. So what we're going to do is we're going to divide this bar into 5 holes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to divide each one in half. And then we're going to circle how many halves we have. Here's 1/2, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer is 10. Now there's a shortcut to getting that answer. There's a shortcut. If you look at these numbers, 5 and divided by 1/2, is there any way that you can get to 10? Well, if you look at it closely, you kind of see that if you did 5 times 2, that would give you 10. And then we think like, what about the 1? So if we multiplied, instead of dividing, if we multiplied by 2 to get 10, that would give us the answer. But this is not 2 right now. This is 1/2. So what if we flipped it? What if we kept the 5? We're just going to keep the 5, but we might write it as a fraction. We changed the division to multiplication, and we flipped the fraction, meaning the reciprocal. We took the reciprocal of it, which would be 2/1. Let's see what we'd get. 5 times 2 is 10. 1 times 1 is 1. 10 divided by 1 is 10. And that's the answer we got with the model. So this method of keeping, changing, flipping, or using the reciprocal is a method that will help us divide fractions without using a model. That's what we're going to do today. Okay? It's called keep, change, flip. I set it up like this every time just because it will help you kind of see what you're doing for each step. Skipping this step would not be a good idea. All right, here we go. All right. Sorry, it's somebody at the door to talk to. All right, so we're on page 11. We're actually going to cross off some stuff and change some things before we get started, but if you can cross off, it says use a model, use an equation. It says the same thing down here. Use a model, use an equation. You cross those off. We're also going to change these problems, okay? 6 divided by 1/3. We're going to change that to 6 divided by 1/3. We're going to do that problem twice, actually. We'll see. You'll see why in a moment. And then this 7 divided by 2/3, we're going to change it to 8 divided by 2/3. We're going to do that one twice as well, and you'll see why. Okay? So what we just talked about, this keep, change, flip thing, is going to help us solve these without a model. But before we do this one, let's think about what it would be, right? 6 divided by 1/3. Well, how many thirds fit into 1? If it was 1 divided by 1/3, the answer would be 3. There are 3 thirds in 1. So each whole has 3/3. If there's 6 of them, that would be 18. So the answer I'm thinking is 18, but let's see how we can get it with keep, change, flip. Now with a problem like this, I would always, oh, got a phone call. Pardon me. Actually, while I was on that phone call, I was thinking, we're going to change this one actually. Instead of 6 divided by 1/3, we're going to change it to 6 divided by 3/4. Okay? 6 divided by 3/4. So it's going to be slightly different. All right. Let's try it out. So first things first, I'm going to write that 6 as a fraction because I want to work with fractions here, not whole numbers like that. Now 6 as a fraction would be 6 over 1. And then I'm going to keep it still division. I'm just going to write it again as a division. Oh boy. But just with 2 fractions. Okay? Then I'm going to set it up with keep, change, flip. So we're going to keep, change, flip. We're going to keep the first number, 6 over 1. We're going to change the division to multiplication. And then we're going to find the reciprocal of the other fraction, be 4/3. Okay? 6 times 4 is 24. 1 times 3 is 3. Now we get to this point, and you're thinking, oh, we're probably done. Not quite, because we have to simplify this. 24, this fraction's improper, meaning the numerator is greater than the denominator. So what you do is almost like dividing it. 24 divided by 3 is just 8. So the answer is just 8. That one wasn't too bad. But we're going to try it again. I'm going to show you a shortcut here. I'm going to show you a little shortcut that I love using, that will help you quite a bit. So we're going to rewrite this 6 over 1 divided by 3/4. And we're going to keep, change, flip. Setting it up the same way, as you can see, but this time there's a little trick I'm going to show you. Okay? Keep the first fraction, 6 over 1. Change the division to multiplication. And then we're going to flip it with the reciprocal. But watch this. At this point, we could multiply. However, we could also simplify. Now, to simplify this, we're going to look diagonally. Now, we should still get 8 as our answer. Watch this. If you look diagonally, look at 6 and 3. Is there a number you can divide 6 and 3 by? Do they have a common factor? Yes, they do. That number is 3. So what I could do is divide each number by 3. Just going to turn the lights back on. 6 divided by 3 is 2. 3 divided by 3 is 1. Now watch this. We should still get the same. Well, let me do this with 4 and 1 too. If I look diagonally here, I can't do anything. There's no number I can divide 4 and 1 by to change anything. So we're done with that. 2 times 4 is 8. 1 times 1 is 1. And now we're left with this. 8 over 1, well, 8 divided by 1 is just 8. So if we simplify the problem when we can, we're going to wind up with a number that's a lot easier to work with. So this is called like cross-simplifying. And if you look diagonally, and if you can divide by the same number for both numbers, you might as well, because it's going to make everything a whole lot easier. All right, let's try another one here. 8 divided by 2/3. Same type of thing. We're going to set it up, and we're going to divide. But instead of writing 8, I'm going to write 8 over 1, just because I want to work with fractions here. Divided by 2/3. So we're going to keep, change, flip. Keep the 8 over 1. We're going to change division to multiplication, and we're going to flip it. We're going to use that reciprocal, 3/2. All right, let's multiply. 8 times 3 is 24. 1 times 2 is 2. 24 divided by 2 is 12. So the answer is 12. But let's try it out with that with the doing cross simplification. Let's see if that works. And if it works and we get the same answer, that's a good thing, because that means that this will work for all problems. Let's see. Setting it up, writing the division, keep, change, flip, keeping it, changing it, flipping it. Okay. Now, let's look diagonally. 1 and 3 is nothing really you can divide 1 and 3 by that will change anything. 8 and 2, however, you can divide those both by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. 4 times 3 is 12. 1 times 1 is 1. 12 divided by 1 is 12. There it is, same answer, but just a little simpler. Simplifying that problem will make quite a big difference in problems like these and in other ones throughout the unit. All right, let's try some down here. Let's try some more. 6 divided by 1/3. Okay, well, the first thing I'm going to do is set it up so that we have a fraction instead of a whole number. 6 over 1 divided by 1/3. Okay, so we're going to keep, change, flip. If you want to try that on your own, go for it. We're going to keep 6 over 1. We're going to change division to multiplication. We're going to flip that fraction. 1/3 will become 3 over 1. Now, if you look diagonally, there's nothing we can do, right? There's nothing we can simplify by, which is fine. So we just multiply. 6 times 3 is 18. 1 times 1 is 1. 18 divided by 1 is 18. Perfect. Feeling good about this. All right. If you want to try these next two, go for it. But we have 5 divided by 2/3. First thing, 5 over 1 divided by 2/3. I would set these up, boys and girls, the same way each time, right? Want to make sure we have two fractions. Keep, change, flip. There's some people who think that they want to go right from here to here. That's not a good idea. It's always a good idea to rewrite it. It's always a good idea to write your letters, KCF, keep, change, flip, because it will set you up. 2/3 as a reciprocal would be 3/2. If you look diagonally, there's nothing really we can do there. So we're just going to multiply. 5 times 3 is 15. 1 times 2 is 2. Now, how many times does 2 go into 15? This is like division. 2 goes into 15 7 times, because 7 times 2 is 14. 2 times 8 would be too many. That's 16. So it goes in there 7 complete times, but there'd be 1 left over, because that 7 times 2 will get you to 14. To get to 15, you have 1 left over out of 2. So the answer would be 7.5. And we're going to be working on this skill a few times during this unit. But that's changing an improper fraction to a mixed number. Okay? All right, let's try this one out here. 4 divided by 3/4. So it's going to be 4 over 1 divided by 3/4. We're going to keep, change, and we're going to flip it. Keep the first number, change division to multiplication, flip that fraction. If you look diagonal, 4 and 3, nope. 4 and 1, no common factors there. You can't simplify it cross like this. It's only diagonally. Okay? And it's only when you're multiplying. 4 times 4 is 16. 1 times 3 is 3. So we're going to do the same thing we did in the last problem. We're going to think, how many times does 3 go into 16 evenly? Well, 5 times 3 is 15, so it'd be 5, and then there'd be 1 left over to get to 16. 5 1/3. Okie dokie. Got one more to do. Here we go. Almost done. Let's see. At summer camp, the duration of a field hockey game is 3/4 hours. Well, I'm going to change this one slightly because we already used this problem above. The camp counselors have set aside 6 hours for field hockey games. How many games can be played? All right, well, we're actually going to change this from 6 to, I don't know, 9. Let's lengthen the time. So I changed that from 6 to 9. We're just going to lengthen the time that we can play field hockey here. Okay, I think we can fit in quite a few games, but let's see. So the dividend, or the number that comes first, is going to be the number that's being divided up. So the 9 is what's being divided up. Now I'm going to write that as 9 over 1, just because I want to deal with fractions here, not necessarily just whole numbers. And we're going to divide that 9 over 1, or 9 wholes, by 3/4. We're going to see how many times 3/4 will fit into 9. I'm thinking the answer is going to be greater than 9, because 3/4 is less than 1. Okay. So what we're going to do is we're going to keep, we're going to change, and we're going to flip. Keeping the 9 over 1, it's going to stay 9 over 1, or 9 wholes. Change that division to multiplication. Flip that fraction. Find the reciprocal, which is going to be 4/3. Okay, let's look diagonally. 1 and 4, nothing there. 9 and 3, though, you can divide those both by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 3 times 4 is 12. Whoop. 1 times 1 is 1. 12 divided by 1 is 12. So 12 games. Now here's the thing. If you didn't do the simplification, you'd still get the right answer. However, instead of doing 12 over 1, or 12 divided by 1, you'd have 36 divided by 3. This is simpler to work with. It's simpler to use. This is a skill that, once we get better at it, once we get good at it, it's going to help us quite a bit during this unit. It's simplifying diagonally. Cross simplification. All right. If you have any questions, let me know. Hope you enjoyed the video, and I will see you soon. Bye-bye.